Hello and welcome to the Cisco CyberOps Associate Lab video series. I'm going to be walking through each of the major labs of the Cisco CyberOps Associate NetAcad curriculum. So let's go and let's jump on in. Alright, for this lab we are doing lab 8.2.8 using Wireshark to examine an Ethernet frame. So in this lab we're focusing on layer 2. So let's jump in, let's see what we can do. Alright, so first and foremost, again, I have the lab 828 off the side of my screen. We are going to be using a virtual lab environment. So we need the CyberOps VM, and we're just going to work through the steps. So these directions are off the side, and I have my VM for my CyberOps workstation up front and centered. So let's get in, let's log into our Cyber workstation. It should be analyst, and the password is CyberOps. So again, read through the scenario. You're going to notice most of it all focuses around that layer 2 frame encapsulation. So step 1 is essentially, actually I'm going to bring that back. So here's what a traditional Ethernet frame header would look like. The preamble, destination address of 6 bytes, that will be the destination MAC. Source address, again, source MAC address. The frame type, any of the upper layer data, so your layer 3 packet would be part of that data. And then we have an FCS checker at the end with 4 bytes total. It's important to understand what our frames look like, so when we look at it inside Wireshark, we understand what's going on. So that's step 1, understanding our frame. Step 2, examine the Ethernet frame in Wireshark. So the Wireshark Capture below will show a packet generated using ping issued from a PC host to a default gateway. I will just, just keep the instructions up. I'll zoom in. So here we've done ARP or ICMP. We were able to pull, and again, this is just an example before we dive deeper into the lab. So examine the Ethernet 2 header contents of an ARP request. Again, with an ARP request, we are looking at our preamble. And in this example, typically the field will be the preamble. It's not really shown in this capture. In this example, we have a broadcast, we have a source, and then we have a data type. ARP, address resolution protocol. It's going to be sent via a broadcast. So all Fs. That is because, again, it's a 48-bit address, or 6 octets, expressed in 12 hexadecimal numbers, 0 through 9, A through F. That makes up our MAC address. So that's our destination. If it's a broadcast, it will be straight Fs. The source address will be our, whatever our source address is. Remember that the first 6 hexadecimal numbers indicate the manufacturer. These are going to be our manufacturer, and then these will be unique to us. The destination address with an ARP request is a broadcast, which will contain all ones, or a unicast type address. The source address is always going to be a unicast. So again, when we're looking at our 3 types of address, if we're talking IPv4, unicast, multicast, broadcast. Unicast is 1-to-1, so one device talking to another device. A broadcast is one device talking to everyone. That would be a broadcast. A multicast is a group, not everyone, but a group. So one talking to a specific group. For example, I may want to talk to all OSPF routers. The OSPF routers would be the group. So one to a group. So I'm going to scroll back up. So we looked at our destination, we looked at our source, we looked at the type. Now we can look at a little bit more detail. we have our frame type. Our frame type is 0806. Because our frame type gives us details, we know that 0806 is an address resolution protocol or an APP request. If it is 0800, so this right here, type, if that was a 0800, it would let us know that it's an IP packet. In reality, that's letting us know what is the layer above it. So for the Ethernet frame, the field will contain a hexadecimal value for the upper layer data. So IPv4 0800, you might have an IPv6, so that would be a different hex value. After that, the data portion, if it was an IP packet, that would actually be the upper layer material. Because it is a ARP request, this will contain the encapsulated upper layer protocols, and that will be between 46 bytes up to 1500 bytes. That way we have our total byte for our entire frame. After that, we have our FCS. That's our frame check sequence, and that is used by the NIC to identify any type of error. So we have a few questions, and then we're going to go ahead and go on to part 2. All right, so let's look at some of these questions. What is significant about the contents of the destination address field? So again, the destination address, if we're talking at layer 2 frame, it's going to be where is it going. Again, broadcast, unicast, multicast. So all hosts on the LAN will receive a broadcast. So if we're trying to find a specific computer with an IP address of 10.0.0.0.1, broadcast will reach all computers on our LAN to figure out who that IP address belongs to. The reply will contain the MAC address of the device that has that IP address. So that destination, again, if it's a broadcast, is being sent to everyone. Next question. Why does the PC sending out a broadcast ARP prior to sending the first ping request? Basically, before the PC can send a ping request to a host, it does need to determine the destination MAC address before it can actually build the frame header for our ICMP request. Again, if it's pinging a local device, it needs to know the MAC address for local communication. If you're pinging outside of the network, well, you still need to know the MAC address for the default gateway. That way you know where to send the frame. So what is the MAC address of the source in the first frame? So if we look, I'm going to scroll up. The source is, I'm going to scroll all the way up. If we look at this, destination, ARP, source is the Intel Core 62626D. Or, in reality, that Intel Core actually is the manufacturer, so the frame is showing you the manufacturer, and then it's giving you the last 6 bytes. So the the MAC address for this is going to be F48C5062626D. Now, if you want to see the IP address, you'd have to go further down to get the additional information. But since we're looking at layer 2, not that big of a deal. That takes care of that question. What is the vendor ID? Intel Corp. So what portion of the MAC address is the OUI? That's the first 3 octets. And what is the source NIC serial? So if this is the first 6, this will be the last 6. And the last 6, 62626D. Again, because the full MAC address is F48C50, that's the OUI. And then the last 6, 62626D, are the serial number portions of that. So that takes care of part 1. Alright, so we're going to move on to step 1, examining the network configuration of H3. We're going to be using the mini nets. So I did a previous video where we tried getting Wireshark to function following the appropriate steps. Never got it working. Did some troubleshooting, finally got it functional. So I'm providing both methods of the video. That way you could do either or. Again, we are doing lab 828 using Wireshark to examine Ethernet frames. So first, I logged out of my machine. I'm going to go ahead and get logged in. CyberOps. I will open up a terminal session. I'm going to go ahead and zoom in twice. Alright, we need to set up our mininet, so we'll do a sudo. We're setting up our lab environment. I hit tab, so I did LA, hit tab. I will do script, hit tab. CyberOps. Topology, it's a Python script. I'll go ahead and get that ran. Password is CyberOps. So it loads up our mininet that we've seen in previous labs. Here's our host 4, router, switch 1, host 1, 2, 3. So again, this is our virtual or mini network created via Python inside of our VM. So what we're going to be doing is opening up our H3 terminal. So we'll do xterm H3. And here we have our terminal. I cannot increase the size of my terminal. I apologize. So, at the prompt of node H3, enter IP address. So, we'll go ahead and do IP address. We can see our loopback. We can see the inet of our loopback. We can see the 5th Ethernet, so if5 or Ethernet 0. That is my IP address. That's my inet address. And this is my inet 6 or IPv6 address. Alright, so if we do Netstat R, Netstat R, we'll see a gateway. So it says default and it says underscore gateway. I do understand the lab guide shows the IP address. This one doesn't. So again, part of this is using deduction. Our gateway is 10.0.0.1. You could also ping around to see what our networks are, but normally they're putting the first usable to our default gateway. Again, not always, but that's the normal process. You can also again look at the Netstat R. This is the screenshot it provided. This is where ours shows underscore gateway versus theirs shows the IP address of the default gateway. So they're slightly different, so that's alright. So if we want, we can clear the cache of any of our VMs. So if we, in our window, for our root SecOps analysts, which happens to be our H3 terminal, we could do an ARP Tack in. That will see what's available. If, let's say, we had a address there, we could do ARP Tack D, type in the address, and that would delete it. If we were pinging around and we seen it, then we could delete it. I'm getting a no ARP entry for 10.0.0.11. That's because when I do my ARP Tack in, I don't have any records, so I can't delete anything that doesn't exist. Alright, so step 2, part C. It specifically says we're going to be using Wireshark -GTK with an ampersand. Basically, the ampersand is just to bring it out. So we'll do Wireshark Tack GTK ampersand. You should get a command not found. This is what we've notified, or what we've seen in the previous video. However, tap enter a few times, get rid of the Tack GTK. So there are going to be some differences. So with the GTK, it would automatically open and it would start the wire capture. With just Wireshark ampersand, you have to start your capture. So I mean, hey, at least it functions. So we're going to modify the steps just a little bit to get it to work within Wireshark. So we are on technically between steps 2 and 3. So what I want to do is I want to start my capture, go back to my H3. I'm now on step 3, ping H1 from H3. So ping with a count of 5, type in the IP address. Alright, after the ping, stop your capture. You can now see echo reply, echo reply, echo reply, and you can see our 5 pings. So we've now completed step 3, A and B. So let's move down to step 4. Step 4 is applying our ICMP filter. I'll tap ICMP in our filter header up here. I can then see just my items 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So I sent 5 requests. I got 5 back. I got 5 responses back. So this is again more of an intro to Wireshark. So now we have to look at, well, how does a Wireshark layout look like? So we're going to have a panel up here, panel in the middle, panel at the bottom. Again, I'm going to drag my instructions over. We're just working through the lab guide. The top is a packet list, the middle is the packet detail, and the bottom is a packet byte. Basically, as you select on any of the items out of the packet list, the details, the middle part, will change. And you can see layers 2, 3, and layer 4 information here. So in the top section, or the packet list, that's where you select the individual packet. That then updates the packet details, or the middle portion. And from the middle portion, as you click on things, it will actually highlight that portion of the bytes. For example, the destination MAC address. It will highlight it in the byte section. So in the packet list detail, click the first frame listed as an echo ping request. For me, that's packet number 4. For you, it might be slightly different. You'll notice our length inside of our virtual machine, inside of Ubuntu, is 98. In the previous video I did on this same lab where we had to switch to a Windows machine, the length was different. So the length is going to be based off of the operating system, so do kind of keep that in mind. It's more than just that, but at this level, that's a simple, easy way to kind of put it. The second line of the packet detail pane will show the Ethernet frame. That's this guy right here. Source destination. So what is the MAC address of the PC's NIC, and what's the MAC address of the gateway's MAC address? So source is where it's coming from. It's coming from my virtual machine's NIC. It is going to the default gateway. So the destination is the default gateway. source is my machine. If you can click the up arrow, beginning at the second line, obtaining more information, you can see what is the least significant bit and the individual bit. You can see additional details by clicking down on the arrows. What type of frame is displayed? That is a good question. So what that means is, what's the type? So here we see the type as IPv4. That just means the layer 3 data is a IPv4 packet. Or you can see the hex value 0800. That is a way to identify that it's a IPv4 frame type. The last two lines displayed in the middle section provide information of the frame. What's the source IP address? Source is 10.0.0.13. That's the IP address of the computer I'm on, and it is going to the destination 10.0.0.1. That is the default gateway. So we're going on to part F. You can click on any line in the middle to see the ICMP, or Internet Control Message Protocol. If you expand on it, you can see additional details. You can see that this was the source, and its response came in frame 5. Again, your frame might be slightly different. This is just a numbering off of mine. So this just goes to show you that you can see where the information is coming from. Click the next frame to get a response. The host is, I double clicked it. You can now see the response. You can now see the MAC address and all of that fun detail. So next, we're moving on to step 6. Step 6 is starting a new capture. So I'm going to go ahead and start a new capture. Continue without saving, yes. I'll move that off to the side. Send a 5-count echo request to 172.16.0.40. So ping taxi 5, that says do 5, 172.16.0.40. 1, 2, 3, 4, 5. All right, it stops. Now stop your capture. So going on to step 7, we can now answer the additional details. So the question is, in the first echo request frame, what is the source and destination? The source is the MAC address of the PC. The destination is the MAC address of the default gateway. Because again, 172.16.0.40 is outside of the network, which means the frame has to be sent to the default gateway in order to connect it outside of our network. So, what is the source and destination IP address? The source IP address is the IP address of our H3 or 10.0.0.13. Destination again is the IP address of whatever device we are pinging, 172.16.0.40. The MAC address, the layer 2 address, is going to be the local address for communication. The IP address is going to be the layer 3 details outside of the network. Layer 3 information can leave the network. Layer 2 is all about that local network. So, compare these addresses to the addresses you received in step 5. Only the address that is changed is the destination IP address because of it is outside the network. Yes, they are all going to the default gateway, but one is going to the default gateway because that's the IP address you pinged. One is going to the default gateway to leave the current network. Layer 2 frames never leave the LAN. If you have an IPv3 address that's outside of the LAN, you still have to send it to the default gateway. Reflection, Wireshark does not display the preamble. What does the preamble contain? It contains 7 octets of alternating 1 and 0, 1, 0 sequences, and 1 octet that will signal the beginning of the frame. It is just really a way to denote a specific pattern so you know where one frame begins and one frame ends. So the preamble is just, again, the 7 octets of alternating 1, 0, 1, 0. Alright, so that is end of this lab. Again, we are doing lab 828, lab using Wireshark to examine the Ethernet frame. This is the lab where we actually used Wireshark, not Wireshark GTK, but Wireshark within our VM to complete the lab. Questions, concerns, anything, feel free to reach out. Thank you very much. Alright, so that does it for this lab video. A few suggestions would be, 1, run through the lab a second time, trying to do it by yourself. 2, I would do a summary of kind of what you learned, where you struggled, and keep that type of journal going so that you can build off of it. 3rd, and finally, take time to reflect. These labs start off fairly easy and then they grow in complexity, so some of the labs you may have to redo a few times to fully grasp what's going on. If you have any questions or any concerns, please feel free to reach out. Thank you.